Right, in this video I'm going to cover the basic workflow when using CST Microwave Studio. I've been given this list of requirements to simulate a substrate integrated waveguide or SIW structure. I'm not going to run through all of these myself, but I'm going to show you how to parameterize a model so that it's easy enough to run through them. If you don't know what SIW is, if you know what a regular metallic rectangular waveguide is, then SIW is conceptually similar. It is a RF substrate, a circuit board with copper cladding on the top and bottom, and sidewalls made of wires. These have been shown to be able to support modes very much analogous to rectangular metallic waveguides. If you don't know what I just spoke about, then CST is probably not the software for you, and I would recommend looking somewhere else. Now, when you start up CST, if you've used it before, you'll have a screen appearing like this with some previous projects on the right hand side and previous templates that you've gone through on the left, but for new users you won't have this. So I'm going to click on Create Project. It will give me the opportunity to work through a template, and this just helps to choose the best settings for the project at hand. We're going to go here, MW plus RF plus optical. That's the one that we want to use. And SIW is most like in the circuits and components. Basically, you just choose what you've got, what your project is, and the topic that it most resembles. Now, I know from past experience that waveguide couplers and dividers seems to work best. The settings here. If you are building some of these other things naturally, then that's will be what we want to use. We want to use the time domain solver. The frequency domain solver can also be used. I'll go through why that is in a few minutes. Dimensions, these are pretty straightforward. One thing that I would recommend looking at is here the dimensions of units of length rather in millimeters and frequency in gigahertz, particularly because of the ranges that we're going to want to be working with. Millimeters and gigahertz are appropriate. If you're doing something with much higher frequency or very much smaller, then you may want to consider using micrometers or what have you. Conversely, if you're doing a very large structure, centimeters or meters may be more appropriate. The frequency range, this can be adjusted later, but for the time being I'm going to go with 56 to 83 gigahertz. 56 to 83 gigahertz. You can set up field monitors if you like. This can also be done later, so I'm not going to worry too much about that for the time being. The last screen just gives you a little bit of summary. It's got this little underscore one here because I've already got a template that I've used similar ones. So I'm just going to leave that for the moment and click Finish. Then CST generates a new project. This may take a moment. Okay, once it's done that, you have in the middle of the workspace, in my case on the right hand side, a list of some tabs, progress, messages and parameter list. The reasons for these will become apparent in a moment. This may be arranged on the bottom if you're a new user. I think that's the default. I put it on the right hand side here just because it gives you a little bit more space to see a longer list of parameters, and I don't need all that much space for the design. Now, to begin building your model, 3D model of what you want to build, up here, the first tab is modeling. Now, SIW is built into a RF circuit board, it is a good idea from the word go rather, to simulate your structures so that they can be manufactured. CST can simulate all sorts of weird and wonderful models, but if you can't actually build them, then your simulations will be for nothing. You'll be wasting your time. So this is something to bear in mind. Find out if you're planning on building any of these things, where you would manufacture them, what the process requirements are, what the limitations are, and do that. So this little block that I've just clicked here is called brick, that generates a sort of six-sided 3D figure, cube or a rectangle, analogous. And you can either pick points with your mouse, or you can press escape, which I'm going to do, and that brings up a little text box or message box into which you can type things, which will help in making our project a little bit more easy to maintain and modify afterwards. Now the name of the first solid, I'm going to call it RF substrate. You don't need to use underscores, you can use spaces, it's just a habit that I've gotten myself into. Xmin and Xmax, these similarly Y and Z, min and max, these show the range of your solid. It assumes that it is sort of perpendicular to the axes. The axes are shown here. I generally like to use X and Y axis as the plane in which the board sits, and Z being perpendicular to that. So I'm going to go type this minus substrate width over 2 Wyman length over 2 minus 2 and Zmin minus. Okay, so as I've typed there, I've used some variable names, substrate width, substrate length, and substrate height. You could also call it thickness if you wanted to. In fact, let me do that just to avoid confusion. And I'm going to name the component board. If I click on preview now, CST will bring up a new box telling me to enter values for these things. So I don't know what size the board is going to be. I can adjust this later on always. I'm just going to tell it that the substrate will be 50 millimeters wide and say 70 millimeters long and say 1 millimeter thick. I can go a little bit later and consult my list of sizes, but for the moment I don't really need to. Now, previewing that, you will notice that there's like a little faint orange line on the left hand side here. So if I click on the view window and I scroll up with the mouse wheel, scrolling with the mouse wheel adjusts to zoom, then that'll show me a little wireframe of what the board is going to look like. If I middle click, then it allows me to pan. Control and click allows me to rotate the view. Click and drag rather. Control and shift also allows me to pan. Alternatively, I can modify here in the bottom right hand corner what I want to do, but I find it most easy to use these shortcuts. I do not want to make the board a vacuum. I want to load a material from the library. Now again, this can be changed later. My instructions was to use Rogers RT Duroid 6002. So let's look for this. CST incidentally has a vast list of materials that are available. Here we go, Rogers RT 6002. I specifically selected lossy. You can simulate an ideal loss-free substrate, but I want to investigate the insertion loss for these substrates. So I'm going to simulate a lossy one, and it's a good idea in general to do that so that you can get a good idea of what your physical hardware will perform like. It will show you that if the dielectric constant for this particular material is 2.94, the loss tangent is 0.0012, the loss tangent is 0.0012, and yeah, electrical properties measured at 10 GHz. This is a rather industry standard thing. Okay, load. So, okay, and our substrate has been created. Step 1 is complete. Next step is to put metal on the top and the bottom. So I'm going to put another brick, press escape again, and I'm going to put metal on the top first. So I'm going to call it top metal. I'm going to make it cover the entire board. You can adjust this as well if you want to, but for the moment, minus substrate width over 2, substrate width over 2, and minus substrate length over 2. And for the Z, the bottom of the metal should coincide with the top of the board, so substrate thickness over 2. For the height, do substrate thickness over 2 plus metal thickness. CST can solve mathematical expressions like this, so it can be fairly powerful. The one consideration that you may want to make, CST does have the option of a local coordinate system. You can see the buttons up here. I don't particularly like to use it, but perhaps you might find that it's easier. Of course, we don't want this to be Rogers, we don't want it to be a substrate, we want to load a new material, and we want to use copper. Gone down too far. Copper pure. Right, so that gives you some electrical properties of copper, electrical conductivity, the rho, and etc. etc. Load. If we preview this, it'll ask us, hang on, what have I done now? Substrate thickness. Should have entered this parameter already. Did I spell it incorrectly? Copy. Paste. Preview. Substrate thickness. That doesn't make any sense. What's happened? Why?